Okay, today we're going to go over 2.1 on writing equations. So we're going to talk about how we translate verbal expressions into what we call algebraic expressions. So I have already filled in the notes on these screens. So if you have your notes with you, you can pause as you go along to get these filled in. So this is what we're working with. 2 times the sum of x and 3 minus 4 equals 4 times x. So we're going to take each of those parts and fill in each of the corresponding components. So 2 would obviously be filled in with a 2. I put a dot here for times the sum of x and 3 minus 4 equals, that's pretty obvious, we got equals 4 times x. So that's kind of a lengthy stretched out equation. So we're going to take that information and condense it a little bit. So this section here, I've condensed into 2 basically times the quantity x plus 3. So by placing this 2 here in front of those parentheses, that's going to be multiplication. Then we had minus 4. So our minus 4 is right here. Then we had equals, and then we had 4 times x. So 4 times x would look like this. So our final answer would look like this. So there we have written, that's an example of an algebraic expression. So the next section is this one here where it says the difference of k and 3 is 2 times k divided by 5. So the difference of k and 3 means to subtract. So we have k minus 3. Is means equal. 2 is obviously 2 times, we just put a dot there. K would stay k, division symbol, and then 5. So now we're going to take and try to condense that. So here's our k minus 3, which I wrote right here. Equals is next. And then we have 2 times k divided by 5. So here's our 2 times k. We've taken that dot out of there because a number sitting beside a variable means multiplication. And then we have division by 5. So this would be your final algebraic equation. Okay, so this next section, let me go ahead and erase the names from last period that I had up here and fill these in. See if I can save some of their work. All right, so let's review this. The first one right here says 3 times a number t. That's going to look like this. 3 times the number t minus 12. So here's our minus 12. And then we have equals, so equals 40. So there's your algebraic equation. Number 4, 10 times a number. So here we have 10 times a number, x. So they specify to use the letter x, is equal to, so we have our equals. And then we have 2.8 times the difference. So we have 2 operations side by side like that. So we're going to take 2.8 times the difference of something. So we're going to have to enclose that in parentheses. And it's the difference of y minus z. So when you have 2 operations like this side by side, you're going to have to include those parentheses. Number 5, a number m minus 8, so that's this, is the same as, so is and is the same as, both of those mean equal, a number n divided by 2. So that would be this part right here. So there's your algebraic equation for number 5. Now our last one, number 6, here's another one of those where I have 3 times the sum. So I'm going to set this up 3 times the sum of something. Well, sum means to add. And it says the sum of d and 4. So d would go here, 4 would go here. Is means equals. And then we end up with 32. So there's your algebraic equation for that one. Okay, these are already filled in, so this is basically taking our verbal expression and we're creating an algebraic expression out of this. These all three happen to be geometric formulas. So this one says the area of a rectangle, we're going to designate that with just A. And we have equals, so equals length, which we're going to use L for that, times width. So I just put a dot in between those. You could even put L side by side with W. Number 2, the area of a circle, so that's A, is, be careful with is because it means equals in this case. So that's is right here. And then it says the product of pi and the radius r squared. So product of pi and the radius r squared. So product means to multiply, so we just put those two side by side. The perimeter of a rectangle, so perimeter is P, and then it says is 2 times the sum of the length and the width. So there we go again, we have times the sum. So 2 times the sum, and then we have length and width. Okay, I just worked through a few of these just to give you some examples. So you're doing the opposite here. You're going to take each of these equations, like right here, and you're going to write a verbal sentence. Now, I do let you abbreviate and put the actual numbers in instead of writing out the numbers. So this one is 4 times n. And one example I used was less 8, because we're subtracting 8, and it equals 12. The second one over here, so we have a squared plus b squared, that equals c squared. So it is c squared, or you could say equals c squared, however you want to say that. So this next equation, I put 3 times, so we have 3 times the sum. 3 times the sum, so that's what's in here. The sum of G and H equals 12. So equals 12. Number 5, I also did, so we have a fourth, so we could say the product of 1/4 x and y would be one way to say it. You could even say the 1/4 times the product of x and y, and then I put is 24 because is means equal. Okay, so I left this example up here. So this is what you're given. You're given this information. We know that A is the cost of one adult's ticket to the zoo. A minus 4 is the cost of one child's ticket, so we know that the cost of a child's ticket is $4 less than each adult. And this is the expression that we need to write a problem for. So it's kind of like you're writing a story problem. So I'm going to read to you the example that I gave the class today. I said, by looking at this, I know that A is the cost for each adult, and there's a 2 in front of it. So that means we have 2 adults who are going to the zoo. And then same thing here. We have 4. This is supposed to say 4. I notice it says 3. So we'll change this out to a 4. So we know there's 2 adults and 4 kids that are going to the zoo. So I started off, we have 2 adults and 4 kids that went to, I said HDZ, which means Henry Dorley Zoo. And then I said, well, we know the total cost for all of them to attend is $38. So I stated that the total cost was $38. And then I said, I have to change this to 4 also. I'm surprised nobody in my class told me about that error. So then I said the cost of a child's ticket is $4 less than an adult because they gave us that information here. So you have to pretend like that you're not even seeing this part right here. You have to pretend like when you write all of these words here, that if you were only seeing the words, you could actually create that equation that's up at the top. So the cost of a child's ticket is $4 less than an adult. And then our final thing, now you can decide. I decided I wanted whoever is writing the equation to find the cost of an adult ticket. So find the cost of an adult ticket. Something else you could tell people to do at the end is find the cost of a child's ticket. So then you would just take whatever A was and then subtract that 4. So this would be your answer. So you're basically writing a story problem for this right here. So if you were to see these words, you would know that those words would create that equation. And that's it.